Okay, the previous video just stopped at question 20. Let's keep on rolling. 21. If 33% of x is 99, comma, x equals, okay. Well, I worded this a little differently in my problem, but if 33% of x is 99, so 33% of means times, I said that a million times, right? So of means times, so 33% times x equals 99. There's my little equation. 33% times x equals 99. As a decimal, it's 0.33 x equals 99. Okay, I'm not going to write over the next problem, but I'm going to divide by 0.33 on both sides, right? So x equals 99 divided by 0.33. I wonder what that's going to be. Let's see. 99 divided by 0.33, 300. Okay, and that would be choice D is 300. All right, 22. What percent of 200 is 250? Remember I said those two words together, what percent? We're going to call that x. So what percent x of means times 200 is means equals 250. So I want a percentage here. I'm going to get a straight decimal when I solve the problem. Divide by 200. Divide by 200. X equals 250 divided by 200. What do we get there? 1.25, a straight decimal, but I'm asked for a percentage. And how do you go between decimal and percent? Two places to the right and slap a percent sign on it. So it's 125%. So number 22 would be choice B. Okay. All right, I alluded to this in when we were doing inequalities. If x is an integer, what's an integer? It's a whole number, including 0 and including the negative whole numbers. That's an integer. If it's an integer, then the solution set of that range there is what? Well, what is this range? Look at x's perspective. You kind of read backwards. X is greater than 6, and x is less than or equal to 7. Okay, so I have to be bigger than 6, so 6 is not included. And I have to be less than or equal to 7. Okay, so the only thing that fits the bill here would be choice B, the number 7. Okay, that would be included because I could be equal to 7. 6 is not included because I'm strictly greater than 6. Okay, remember this 0 with the slash through it, that means the empty set. That means nothing. Okay, so choice B is my answer there. Okay, we didn't talk parallelograms, but we talked other quadrilaterals, four-sided figures. How many degrees are in each unmarked angle of the following parallelogram? Okay, when I have a closed four-sided figure, think of a square, 90, 90, 90, 90. I've got 360 degrees in that closed square. Okay, same thing with a parallelogram. Okay, so I've got 360 degrees to play with here. Well, I know that 50 and 50, I know 100 is taken up there, right? So 360 minus 100 would be 260. Okay, and then they're split evenly between the two sides, right? So there has to be 130 and 130 in order to make that work out. So just play around with it, you'll get it. It has to be 130 each. All together, I'm going to have 360 all the way around. All right. Let's do it. Question 25. All right, simplify. See, square root of 45. Here the calculator's not really going to help us, okay? And I know your calculator's different, but if I take the square root of 45, I got to even find my darn square root button. I don't use it very much. I know it's under my x square button. There it is, or above it. Now, square root of 45, I'm going to get some goofy decimal. 6.7, blah, 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 blah. That's not one of my choices. I'm asked to simplify that radical 45, okay? Remember what we did. We said we need to find hidden perfect square roots inside of a 45, so we need to factor the 45. Well, 9 times 5 is 45, right? And 9 is a perfect square root. So this is kind of an intermediate step I don't always show, but that's the equivalent. I can break it up into two little radicals, and we know the square root of 9 is 3. Square root of 5 is some goofy number, so we leave it square root of 5. And look at that, one of my choices is 3 times the square root of 5. Okay? All right, sweet. 26. Barry has 4 more cards than Ken. Together they have 44 cards. If X represents the number of cards Ken has, then which of these equations will represent the total number of cards? Well, think it through a minute here. Barry has 4 more cards than Ken. So if they didn't tell me to use X, I would write Barry, B for Barry, equals whatever Ken has plus 4 more, right? Barry has 4 more cards than Ken. Okay? And then together, they have 44 cards. So Barry plus Ken together equals 44. Okay? See how that's, the information's right there. I just had to turn it into something more mathematical looking. Barry has 4 more cards than Ken, so Ken plus 4 equals Barry. But together, Ken plus Barry is 44. So now they tell me if X represents the number of cards Ken has, okay, so I'm really supposed to be using an X plus 4, so okay, I'll do that. Which one of these equations will represent the total number of cards? Barry plus X equals 44. Now I don't see anything that looks like Barry plus X equals 44 over here in my choices, right? But I need to kind of put these together now. I have a representation for Barry. This is like a system of equations. It really is. I have a way to represent Barry. I'm going to call Barry X plus 4 instead of calling it Barry. So I'm going to substitute that information right there. Okay, so instead of calling it B, I'm going to call it X plus 4. So X plus 4 plus X equals 44. Okay, and if I clean it up a little bit and combine my terms, I'm going to have 2X plus 4 equals 44. And if you look, that is one of my choices there, choice C. Okay, now it could have been shown a little differently. Maybe they subtracted the 4 from both sides and they showed, 2x equals 40. We'd have to pick up on that, and we'd have to play around to see what we did versus the choices. Who knows how they're going to present those choices. Maybe they'd even go all the way and divide by 2 and divide by 2 and say x is 20. And say, which one of those is correct? That could have been a choice. X equals 20. So watch out for it. Play around with it. Make sure it makes sense. Okay? But that's how I would do 26. 27. A patient is to receive 3 grams of a medication over 6 days. If he is to receive 2 equal doses of the medication per day, how many milligrams will he receive with each dose? Okay. Well, baby, a patient is to receive 3 grams of medication over 6 days. And then the question is asking us about milligrams. So number one, I would get this 3 grams turned into milligrams first, before I even do anything else. 3 grams equals how many milligrams? Well, if you remember, the scale was decicentimilli, 3 steps to the right. So 3,000 milligrams. So a patient is to receive 3,000 milligrams over 6 days. Okay? I would even write that down, maybe off to the side. I gotta think about how I'm going to use that. Okay? That's the dose, 3,000 milligrams in 6 days. If he is to receive 2 equal doses of medication per day, how many milligrams will he receive with each dose? Okay, well, if I did this division, 3,000 divided by 6, that would just be like having 1 dose per day, right? If I go ahead and divide 3,000 divided by 6, $500, okay? 500 what? Look at the units. Milligrams per day, right? The units tell the whole story. If I crunch the numbers, the units didn't change. They're still milligrams per day, but instead of calling it 3,000 milligrams in 6 days, that's the same thing as 500 milligrams in 1 day. You can put a 1 there if you want. In 1 day. Okay, so I'm getting closer. I know each day this patient gets 500 milligrams, but now I'm further told that the patient's going to get 2 equal doses per day. So that 500's got to be split in half, right? 250 a crack. So 250 milligrams per dose, because there's going to be 2 doses per day to make up that 500. Okay, so you got to think it through a little bit and understand the question. And some of these questions are worded a little tricky, I'll be honest. Okay, think it through. Don't forget about your units. Units tell the whole story. And we were told, first of all, grams per 6 days. So if you stuck with grams, now you might be way off. Okay, so first get the unit you want that they're asking for, break it down into a unit rate, and then pay attention to how many doses per day. Okay. Woo! That was a good one. All right, 28. If 75 milliliters of solution contain 30 milliliters of a specific medication, how much of that medication will be needed to provide 120 milliliters of the same solution? Classic proportion, but be careful because everything is milliliters here. We got to get it right. 75 milliliters, I'm going to say S for solution, so I don't forget. Okay, 75 milliliters of solution contains 30 milliliters, I'll say M for med, of the specific medication. I've got to match solution on the top and med on the bottom, otherwise it's going to be wrong. Okay, how much of that medication will be needed to provide 120 milligrams of the same solution? So I'm given the top piece here. I'm given milliliters of solution. I don't know the bottom piece. Okay, it's essential to set it up correctly. Everything is milliliters. That's why it's confusing. If it were something else like grams per milliliter, then you just match grams per milliliter on the other side. No big deal. But in this case, it's all milliliters. But milliliters of what? Milliliters of solution versus milliliters of the good stuff, you know? So we got to just keep it that way. So now that I've done that, let me forget the units because it's too messy. 75 over 30 equals 120 over x. Classic proportion. We're going to multiply, cross multiply. 75x equals, if you take 120 times 30, you're going to get 3,600, right? Divide by 75, divide by 75, and we're going to get x equals 3,600 divided by 75. What's that going to be? 3,600 divided by 75 equals 48. Okay, is that the question we're asked? We are, right? How much of the good stuff is going to be needed? So 48 milliliters. So 28 would be C. All right. How many liters are equivalent to 300 milliliters? Classic metric scale, you know. It's kilo, hecto, deca, and then in this case liter, deci, centi, milli. I'm running out of room. Okay, that's my basic scale, right? What am I going from? How many liters are equivalent to milliliters? So 1, 2, 3 places to the left. Take that decimal after the 300 and go 3 places to the left, so it's going to be 0.3 liters. Ooh, that's not one of my choices though, is it? Uh-oh, I'm screwed. No, I'm not. 3 over 10, right? Fraction 3 over 10 is the same thing as 0.3 liters. So a little trickery there with the fractions. Pick up on it. Okay, don't give up if you're sure you're right. Just the answer's probably hidden there somewhere. Okay? All right. 30. 4 equal squares have been placed side by side to form the following rectangle. If the perimeter of the rectangle is 120 centimeters, what is the area of one of the squares? All right, we're talking different terms here now. We're told the distance around the rectangle. Okay, of course, not like I drew it, but the 4 nice sides. The distance around, that's perimeter, equals 120 centimeters, right? Well, we know that this rectangle is made of a bunch of squares, okay? And we know all the sides of the square are the same, so I'm going to label them. I'm going to call it just, side S. So that's an S, that's an S, 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 and S. All agree? So to walk all the way around this rectangle, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these S's, whatever S is. 10S equals my distance all the way around, 120 centimeters. Okay? So I can solve for S and divide by 10 and divide by 10, and I'm going to get S equals 12 centimeters. Okay? That's the length of one side of one little square, but that's not the question. The question says, what is the area of one square? Okay, so we have to remember area of a square. It's length times width, but because the length and the width are both the same, we just call it S times S, or we call it S squared. Okay, so I need to take that 12 centimeters, and I need to square it. Okay, 12 times 12 is 144. Centimeters times centimeters becomes square centimeters, and look at that. 144 square centimeters. Okay, all good there. 31. I may have to break this up into 3 videos. We'll see. Which one of these numbers is the smallest value? Well, we need to get some consistency. You can make them all fractions, make them all percents, make them all decimals. I think making them all decimals would be the easiest, right? So we can compare them side by side. So what's 1 divided by 11? I don't know. It's 0.0909, something like that. Okay. Well, 0.45 is clearly much larger, so we can weed him out. 0.7%. How do you go from a percent to decimal? 2 places to the left and drop the percent sign, right? So this would be 0.007. Okay, so that's looking like a strong candidate for the smallest. 3/20, I don't think that's going to be that small, is it? No way. 0.15. So again, we're being asked to find the smallest, so the smallest will clearly be C. Okay. 32. Of 60 patients treated with a certain medication, 24 showed no improvement. What percentage of patients improved? Okay, here another little, trickery in the question. You're tempted to grab that 24 and start running with it, right? But no. 24 showed no improvement, so how many improved? Well, it'd be 60 minus 24 actually improved, right? So that would be 36 people improved. And we want to know what percentage is that. So, if I wrote out the classic question, 36 is what percent of 60? That's the classic question I would have to write. How would I turn that into an equation? 36 is means equals, x is my mystery percent, times 60. I'm going to solve this equation by taking that 36 and dividing it by 60, right? Divide by 60 on both sides. I'm sorry, I'm running out of room. X equals 36 divided by 60, but I'm going to get a straight decimal when I do that. 36 divided by 60 is 0.6 as a straight decimal. But I'm asked to find the percentage, so 0.6, of course, is 60%. Okay, so it's going to be choice A. All right, sweet. A temperature of negative 15 degrees Celsius is equal to how many degrees Fahrenheit? Okay, we did a couple of these in the video. I didn't do any negative numbers. I should have. So my apologies there, but it's no different. We just got to be cautious with our negatives. The formula is 9/5 times whatever these degrees Celsius is. Well, now it's a negative 15. And then plus 32. So I need to take negative 9 divided by 5. Okay. 9 divided by 5, and then I can times it by a negative 15, and again your calculator is a little different with the negatives, but even if you didn't want to mess with the negative, just multiply by 15, get your number there, 27, but now understand that's a negative 27, okay? Plus 32, well negative, plus negative 27 plus 32, one's positive and one's negative. Remember, I'm really going to subtract those absolute values, and I'll get a 5 when I do that. And then I got to see who wins the battle of the signs. The big guy always wins, right? 32 is bigger, so it's a positive 5. So my answer is going to be positive 5. A state sales tax is 7%. If the student paid a total of $37.45 for a uniform, what was the price of the uniform without the tax? Okay, so I've got my price without the tax. I have to give that some kind of name. I guess I'll just call it price. So price, what do I want to call that without the tax? I'll just use the word cost. Maybe that's not the best one, but price without the tax I'm going to call cost. So my price with the tax equals my cost without the tax, right? So I'll write it. Without tax plus the amount of the tax, right? Obviously. The price with the tax equals the cost without the tax plus the tax itself. But what is the tax itself? The tax itself is 7% times that cost without the tax. Not now. Okay, that's how we find it. So let me turn this into a little more of a formula, if you will. I'll call price without the tax P equals some cost plus 7% times the cost. Okay? Well, I know a little bit more than that, though. State sales tax is 7%. I'm going to pay $37.45. That's my out-the-door price. That's with the tax. So $37.45 equals cost plus 7% times the cost, right? Well, if I work this here, cost plus 0.07 times the cost, that's how I would represent 7%, right? So that's going to be 1.07 times the cost, okay? And all these equal 37.45. How do I solve for cost? I divide by 1.07. 37.5 divided by 1.07 equals $35. That would be my price, my cost, what I identified as the cost without the tax. Now, there's no cents here, right? 35 even, so it would be 00 on the cent column here, and if you see, that's one of my choices here. Choice C, $35 and no cents. Okay? All right, 35. Classic proportion here, 3/7 equals 5/x. It's just like reducing a fraction or unreducing a fraction, these proportions, okay? Just think of it that way. I could sneak it in here. 3/7 equals 5/x. I cross multiply, I get 3x equals 35. I divide by 3, I divide by 3, I get x equals 35/3. Is that one of my choices? Yeah. Otherwise, maybe it was some decimal or something equivalent to 35/3. But in this case, the 35/3 is right there. Looks good. Classic percentage question, right? We've answered this a million times. What percentage of 80 is 50? What percentage? That's my unknown. X. Of means times 80. Is means equals 15. X times 80 equals 15. Solve for x, but I'm being asked to show it as a percentage. When I do this little maneuver, I just get a straight decimal. I don't get a percent. 15 divided by 80 equals 0.1875. Okay, how do I turn that decimal into a percent? I move the decimal 2 places to the right, and I slap on a percent sign, so it's 18.75%, and that would be my choice A. Okay? All right, you know what? I know it's only 4 questions left, but I'm going to go ahead and pause it, and we'll wrap it up with one more video.